Okay. Hello, my friends. We had a small glitch with the camera, but we are live. So, hello, welcome to another DevNation Tech Talk this Friday. And I'm your host, Edson Yanaga. And we'll be talking about behavior is easy, state is hard. I think it's a very nice opportunity because this week, Java is turning 25. So, we're celebrating the 25th Java anniversary. And I think one of the most common mistakes that we have when we're dealing with Java programming is the fact that, well, maybe the bugs that we have when we're dealing with behavior, which means the bug caused by the lines of code that we're coding, they're common, but they're kind of easy to fix. But the bugs caused by inconsistent states, at least from my personal experience in my career, these are the hardest one to fix because, you're looking at a bug and that variable should never be null, yet it is, and you have a null pointer exception in production. Or you have that particular other variable that should be always greater than 0, or you're expecting a string with at least 5 characters or something like that, but yet you have like a string with 1 character. It happened, it is in your code, and you're just wondering, how the hell did this condition happen? Well, today I'm going to try to share some best practices for you trying to deal with this kind of inconsistent state. Let me try to share my slides here. And by the way, I'd just like to say hi to everybody that is on the chat. I can see that we have DJ Maddie. Thank you very much for being a frequent viewer of our videos. I can also see Sebi. I can also see Tiago. Thank you very much for joining us on our stream. And just keep posting. I won't be able to be checking the chat frequently because today is only a 30-minute talk. But just in case I have some time, I hope I'll be able to see it. Okay. Here I have my slides, and by the way, I just shared on the chat too a link to my blog post calling about 97 things. 97 things, a book published by O'Reilly, and I think it was released this week. At least that's when I noticed it was published. And the subject of the talk today, behavior is easy, state is hard, is one of the articles features on the book. And by the way, even my article is one of the featured articles right here in the talk. I hope you can enjoy. In this particular article, I only talk about this concept very briefly in a very abstract way. Today, we're going to try to show you some more code, right? So, fun facts about me. I'm a Brazilian Japanese. My Twitter handle is @Yanaga, just in case you want to follow me. And I'm also a Java champion and a Microsoft MVP. And I've dedicated my past 25 years to Java. That's why I'm like twice as happy to have Java's 25th anniversary. I'm celebrating 25 years of coding with Java, so it's a very nice opportunity to be talking about Java today. And remember, tomorrow, May 23rd, we need to celebrate 25 years of Java, and I'm pretty sure everybody will be celebrating worldwide this great accomplishment of this great technology. And some of the tips that I'm going to show you today come from this book, Effective Java. And actually, I have it here in my hands, a physical copy of the book. If you never read it, I strongly recommend you to do so. We have the latest version of this. And this particular copy, I'm trying to open the page. I had the pleasure. I don't know if you can see it properly, but Joshua Block himself signed this copy for me when I met him at DevOps France, I think 2 or 3 years ago. So I'm super proud and super happy to be sharing some of the concepts of the book and some of the concepts for myself from my personal experience, right? Joshua doesn't deal with high-level frameworks and abstractions that you need to deal when trying to deal with immutability, but let's see how can we integrate all of this stuff. And also, some of the examples that I'm going to show today are using the Eclipse Collections. If you want to provide true immutability, which I think is one of the best ways for you to tame inconsistent states. There are many different list collection implementations worldwide. I've used Guava in the past, but lately I've been using Eclipse Collections, which has a very nice API and provide the features that we want into this particular case, which is immutable collections. And you have like different kinds of collections too, just like other libraries did. But I think that Eclipse Collections, they've done a great job. Kudos to my Java champion friends that are developing Eclipse Collections. They've done a great job, and I think it's a very nice opportunity to show off some of the use cases, even if it's small. right? So, but, oops. But enough of the talk. I know you're eager to see some code, so let's try to do some live coding and see what we can accomplish in this remaining 25 minutes. And remember, if you have any questions, put on the chat. I hope I'll be able to be checking that at least in that. So here I created a project using Visual Studio Code for Java, which is my favorite IDE these days. So let's try to create a POJO. So I'm going to create a person.java class, and it's supposed to be a POJO because you can use it in any framework, and actually your domain business logic should be provided as this way. And if you ever learn a domain-driven design, you might have heard a bit about entities and value objects. If one should be the other one or the other. So if you think about the person, it really depends on your domain model. In most use cases, this should be an aggregate or an entity or something like that. And a clear distinction that I usually tell people, if you're deciding between an entity or a value object, I mean, if the properties of your particular class or your particular entity, do they change over time? For example, you have a person. If this person changes their address number, if the person changes their phone number over time, then it's very likely that it should be an entity or an aggregate. On the other hand, if you have a phone number, if you have a phone number 123, and you have another phone number 123, are they the same thing? Which means even if you have like two different objects in memory, can you replace one for the other? And the semantics of your code, does it change? If it doesn't change, then it's a value object. If it's an entity, then that's something that should be mutable. If it's a value object, it should be immutable. So value objects are immutable. Entities can change over time, so we can design them as pure immutable classes, but it doesn't mean we can't prevent some kind of mutability. So most of us also use JPA, like hibernating JPA these days for persistence, for ORM persistence in relational databases. And we know that if you're using JPA entities, it's very hard for you to design immutable classes. But again, it doesn't mean that we can't provide some immutability, can't we minimize the mutability of those particular entities? Okay, so I'm going to design this as a particular, let's try to make everything immutable, and then we're going to create another class which has some partial immutability. Okay, suppose for example that you have a person, and this person has an age, and this person also has a name. So this particular person has two different properties. We'd like to say that, well, age should always be positive. You can't have somebody with a -1 wage, even though we would like to travel back in the past. We can't be younger than 0 years. And suppose that our name also should be, I think that in most languages you should have at least one character. I don't know if like in Chinese or Japanese you might have a name with only one character. But suppose that in the Latin, using the Latin alphabet, you should have at least one character. So the name length should be at least greater than 1. So how can we design this class for to achieve this? Some people would argue that, well, maybe that's a JPA entity, and later I could provide a long ID or something. I could provide some validator annotations, so I could use Hibernate validator to validate that. I think that the best way for you to guarantee the state, the invariant of your particular class, is to do that when you're constructing the objects. You know, if you guarantee that the object state when it's built is consistent and you can't change it later, then it's very unlikely, if not almost impossible, that you have an inconsistent state when your application is running, unless you have like a JVM bug or somebody is using like dark arts using reflection trying to change something. You won't have inconsistent states. So I'm gonna skip the discussion about, well, whether somebody can change the values using reflection. Most of the time you shouldn't. So how do we design this person class to be immutable? Of course, somebody would say, I could just declare this class as final and provide everything as final fields. So if my class is final, I only have final fields. They will have to be initialized during construction, so I should be good. The problem is that if you define your class as final, you will have issues with some frameworks during runtime. For example, if this is a JPA entity, you probably have issues. And other frameworks also might have issues when you're trying to expose this entity to the outer world. So declaring this as a final, from my particular experience, is not a good approach. So we don't declare that as a final. Even allow us, for example, if later we want to provide some more types. For example, if I have one particular type of person, another particular type of person, I could create like a subclasses of this class. It allows us to expand our possibilities later. And let's create a constructor. So right here, I want to go to source action, generate constructors. So I'm going to select all the fields and hit OK. So I created a constructor. I initialized all the fields. The best way for you to make this class immutable is to provide everything as final fields. If you're designing a JPA entity, we'll have another example dealing with that because JPA entities can't have final fields. And here I'm going to change the constructor to private. So I can see that Thiago mentioned effective Java. And I can say hi to Nelo too. Thank you for coming. Thiago mentioned effective Java. Yes, the tip that I'm sharing is from effective Java. So you might be familiar with that. And you know, if you have a private constructor, you know that the only class that can invoke this particular constructor is person. Any other subclass wouldn't be able to do that. Any other external class wouldn't be able to construct an object. So you know that the construction is limited, and this is the only one that could be creating new objects. And I also like static factory methods, so I'm going to create a factory method here. I'm going to provide for now int age and string name, which is exactly the same parameter as the constructor. Okay. And how do I guarantee the invariants? I usually put my invariant code here in the factory methods. So if I want to check, well, let's see. And by the way, I just created another class called Preconditions. You could import something from other library, but this class is so simple that probably you should be a good thing for you to implement that in your project. What I'm doing, I'm creating a Preconditions class. This class is final. Even though I didn't declare final, nobody can instantiate it, and nobody can subclass this class. So it's truly immutable. I have a private constructor, which guarantees that. And I also have a static method saying check argument, which basically does the most dumb thing. I just get a Boolean as an argument, and if it's not positive, it's not true, I just throw an illegal argument exception, which is the right and exception to be thrown in this particular case if you have an illegal argument. So what I can do preconditions, check argument, age must be greater than 0. Suppose that technically somebody could be 0 years age, but let's skip for this particular business use case. And check your argument name dot length, or name can't be null, right? I could even create another method just to check this, or I could do both. Maybe name different than null and name dot length should be greater than 1. So I have these preconditions. Now I guarantee that if a person object is created, it will have a consistent state. And very likely you will be able to later provide like getters and setters for that. And you have an immutable class. And another interesting point is that here I can use a factor method because first, all of the fields are mandatory, so I have to provide an age, I have to provide a name, I don't have like any optional arguments for that, and I only have like 3 fields to initialize my class. So you have like 3 fields, then it's going to become more complicated. But suppose, for example, that you would have like 4 fields, and 3 of these fields are strings. So string A and string B. Then suddenly your API becomes very cluttered. You have like 4 arguments. It's very hard for you to remember all the arguments, and you have 3 arguments of the same type. So string, and sometimes your IDE doesn't show to you the name of the argument, so you would have to go to the Java doc. Well, the first string, is that the first name or the last name? Or is it something else? Is it the title? So what is the order of the arguments? So when you have multiple arguments, and especially when you have multiple arguments with repeated types, it becomes very complicated for you to use your API. And in this particular case, they're all mandatory. Maybe the title of the person is optional. How can I design something to use it? Well, in this particular case, you would create what we call a builder. So how can we design like optional fields using a builder? So suppose that I have here, I still have, for example, final string title. And this title is optional. I don't have to this, or else I could provide something that as default value could be empty, an empty string. But I want this to be initialized. So what can I do here? I can just provide this particular string title. I can say this.title. This is title. And now I need to provide this. So now instead of using a factory method, okay, we're going to use another construction, which is a builder. So usually builder class is a static class inside the same class. I can say builder, and this particular builder class is going to have the same fields that I had before, but they don't have to be final. If they're mandatory, you can design as being final, but from my particular experience, I know it's very useful because most of the framework these days, they require you to provide to follow the Java Beans specification. So it's much easier in most of the cases if you don't make them final, so you can generate the getters and setters. Okay. So I go ahead the string age, but suppose the title by default it could be empty. And in this particular case, I could provide the get all the getters and setters. So let's see if we can do that very easily. Source, generate getters and setters, provide all the ones. And I could be using a factory method here. I'm just not using because, as I mentioned before, if you design it as a plain old Java bean with like public constructor, everything as getters and setters, you will be able to use this class in much more frameworks. But this is a builder. How do I construct my true class? Well, what you could be doing right now, then you could be creating, like, for example, a public person build, and then you could be return new person, and you can provide the proper age, name, and title. Right? Since it's inside the same class, you know that that we can access the constructor because we're still inside the same class. It's static, and you could run the preconditions here. I can copy this code here in this particular preconditions, right? Oops, come on. I have here, my keyboard is not behaving correctly today. Okay. Can't format the code source. No, format. Come on. Format document. Yeah, something's going wrong. It's not formatting, but you can get the idea. You can check everything, even the title. You could be checking the state of the title. It needs to be empty, can't be null. You could be providing all of this. And Tiago seems to have a question here. So Juan, hi from Colombia. And Tiago, doesn't make any difference inside the preconditions, private constructor with insert the throw new assertion error. Yes, effective Java recommends you to do that. I could have done that. I was just lazy. This assertion should never be executed, but just in case, I think it's why not? Like, I think it's a good practice. I just omitted because I'm lazy and I was like kind of in a hurry trying to craft the demos. But yeah, good point, Thiago. Okay, what else can we do? But I would argue that this class that I created is not optimal. Even though I created a factory method, I created a builder, this class is not optimal because I'm using a lot of primitive types. And you know that another common bug that we find these days is that we have what we call primitive obsession. Everybody's using primitive types in your code, yet we're using an object-oriented language. If you want to have a rich domain model, we should try to avoid using primitive types most of the times. We need to create our own types. And for that, let's use another example that can be used in JPA. Okay, let's try to here and let's create an order here. Okay. Oops, I forgot the extension. Order.java. Yes. Now it's class. So I have here order.java. And if you design this in a JPA entity, it's very likely you're going to add an entity. You also have to provide a private long ID. And a generated value. Okay. What else does our order have? Our order could have a number. So I could provide, for example, private int number. And what else? An order could have like multiple items. I could design this as a public. Let's put a list and order items receives, and let's use like, for example, an Eclipse Collection class list.mutable.empty. Want to create an empty list, and this, let's try to fix this by creating this class. Okay, so order item, yes, it's here. Save the class, doesn't complain anymore. So here I created an empty mutable list. I could use, for example, the mutable list type returned by Eclipse Collections, which would be super nice, but it wouldn't work well with JPA. So I have to stick with the standard JPA types. Probably over here we'll have to map like a one-to-many or something like that. That's something that I could be doing, but let's skip this because we don't have time today. I intend to record another video where I'll show up like all the proper features of using JPA to here. I just want to check you, like show like many different options for you to be doing, and later we can like share more videos with the proper details of how achieving like that in production. So we have get items, and this mutable makes explicit that this list is mutable. And it's not uncommon, for example, that sometimes when you add an item to your order, maybe you need to compute other things. Maybe you have a limit of how many items you can have in your order. For example, maybe this list should be limited to 10 items. Or maybe if the order items, for example, you have a certain quantity in each one of the items, maybe the total, if you multiply each one of the items, the internal quantities, the total overall can't be greater than 100. So you have this kind of constraints. And if you have a public mutable list that you expose in your API, you won't be able to guarantee these internal states. So what can we do? So the traditional way for you to be doing get number and get items, by the way, number here, the order number should be an int. It's very likely that we'll need to create a value object here, called order number, because maybe your order number should have at least 4 digits. You need to guarantee that. And maybe this particular 4 digits should be printed like 2 digits dash 2 digits. So how do you enforce these things? The easiest way for you to be doing that is to create another class called order numbered and providing these constraints and all of these helper methods inside that. Okay. But let's focus here. Let's assume just int, and you have here an ordered item. If you expose this, it's completely mutable. So how do I minimize mutability when I'm trying to use JPA entities? I could say, well, let's try to do this. Let's immutable of all items. When I'm doing that, I guarantee immutable list. I just change the type here, immutable list. Okay, I just changed the type here, and now you have all the methods from the list. I think I'm mistaken this some of the times here. I'm returning an immutable list, which means that if somebody tries to add, to remove an item, you will have an exception during runtime. So nobody can change the list, but your order class. And what else can we do? Well, but how do I add an order? You could provide an adder method. So I like to design like fluent APIs. That's why for most of the adder methods, I just return the same type in which I'm currently using. For example, I could add item, order item. I could say, well, preconditions dot check argument item can't be null. And if it is okay, I can say, well, items dot add, and I can add this particular item. Okay. And in the end, I can return this. So I created an header. I could also create a remover, and suppose also that I would like a method that, well, maybe for this particular order item, I want to add 1 plus of each one of them, or I want to multiply the price for 10% for each one of the items. I want to give an overall discount on the item on each one of the items, for example, or I want to enforce a condition that I can't have like 2 items with the same type. If you had like 2 items with the same product, I don't want to have like they duplicate. I just want to add the amount in my current item. So if you have a centralized point of logic, everything that you do here will guarantee your internal state. So that's one of the ways that you can enforce. Nobody can change the internal state of your class, but your own class. That's one of the ways for you to be doing that. And I have here Thiago is also says better to insert table equal table name equals to order info. So yes, because order is a SQL reserved keyword. It's a very common, but it's just using an example here. But yes, if you try to create that, you have an error. Okay. A better way could be like a purchase order. Okay, or invoice. I could create other names that doesn't conflict with, for example, SQL reserved keywords. But yes, Thiago, you're absolutely right. Okay, and here, for example, in the order item, I could design this as an entity too, a JPA entity, which means uh, it could be an entity, but depending on if you have an item, this particular item, if it does have like a quantity, and it has a particular product, and it has the price of this particular one. If I have 2 different items with the same values, are they the same thing to your application or are they different? For most of the applications, they are the same. So it doesn't matter if you replace one for the other, you will still have the same semantics. On the other hand, for example, person, I like to give this example. I am person. My person is Edson Yanaga. I have a birth date. I have other things. But even if I change my address, even if I change my name, even if I change my phone number, even if I change my sex later, I'm still the same person. So clearly, I can't replace another one with the same name. And actually, there is another Edson Yanaga out there. Actually, there are 2. My father and my cousin, they both are at Yanaga. We just have different middle names, but we have the exactly same name, the exactly same surname, and yet we are completely different entities. So clearly, during your code, it should be person in this particular example should be in a particular entity. By the way, it gives me an error. Me and my father, we can never fly on the same flights because the ticketing systems from the airlines, they don't allow 2 people with the same name inside the same flight. So when I had to book tickets for myself and for my father, I had to call because the system would never allow us to buy the ticket online. I had to call and just changed one of our names. I became Edson something, and my father was just Edson. So we could have tickets, and I had to explain when I was trying to boarding. Yeah, my name is different, but that's because, well, you know what happened. Okay, so it doesn't have to be an entity. I could just design that as embeddable. So embeddables guarantee that we're dealing with a value object, and here we could enforce other types of guarantees. But suppose that an order item, for example, would have an amount and couldn't have a price. Okay, here I have a particular price, and we should be good because both integer, int, and big decimal, they are immutable classes, but suppose that I don't know if a big decimal is immutable. Like I don't want to rely on something that I read on a book. I need to guarantee that this particular class is immutable. And we have a lot of JDK classes that are immutable. For example, if you're still using date from JDK 1.0 instead of using the new date API, you're probably dealing with mutable classes. So how do I do? I want this particular price I want a guarantee that is also immutable, okay? So how can we do that? Let's create a new class called money. Okay, this particular class, I would create a factor method, I would guarantee internal state, and I would have to make it immutable. Okay, and I just realized that I'm running out of time. So let's try to skip this. So I created money. Suppose that I created the private final value of big decimal. Suppose that I created a constructor, for example, private money. uh, Suppose that I create a constructor and everything is doing well. How do I use this particular class in a database column? Well, if you ever used the JPA before, you know that we have something that we call attribute converter. So I could be designing, for example, money attribute converter.java and just implement this particular interface. Implements attribute converter from money, and I'm going to match to big decimal in the database. So money. Big decimal, import, yes. And here I could also use the JPA annotation auto apply true, so I don't have to type at convert in each one of the fields. So in this particular interface, I need to implement two different methods, convert to entity and convert to database column. Okay, and in this, if I want to return the internal value, money to attribute, I would say attribute dot value. And you know, for proper information hiding, this value attribute in this big decimal class would need to be private, but I'll make an exception since we're designing all of these classes, both the money and the attribute converter in the same package. I'm going to use the package private visibility. We're not breaking encapsulation, and we're allowing LPE to be cleaner without having to expose here the get value method, right? So I would design this money attribute converter, and it's fine. Here I could also say, well, if I have designed this factor method, I would say money of DB data, and I would provide that properly. Okay, what else can we do? Last example, because we're already out of time. I have a particular order. I designed it to be immutable, but I still want to expose that to my view using JSON, for example. I could create an order DTO class, and this particular order, maybe ID and number. So I'm just going to use the simple one, private long ID, private it number. Okay, I would probably try to generate the getters and setters, but the way I like to provide DTOs, if you want to expose them and you want to receive, for example, that as JSON, how do I guarantee that I'm receiving something valid from the UI? Do I need to add like my validation annotations, or I can do something else? Well, the same practice that we created, for example, for person here. I added the preconditions, I created a private constructor, I created a factory method here, can be applied to that online. So I could also be creating, let's try to do this. You can, if you're using JSON, you can use this as final. You can, for example, generate a constructor. You select all the fields and you hit enter. You can provide a factor method. UTO off, and let's just be lazy. Copy this stuff. Return new order DTO. I could type the preconditions here. And how do I make sure that I can use this? Because all of the frameworks that I know wouldn't be aware that, well, I don't have a public constructor. I can't set everything through getters and setter. Well, if you're using JSON, you can just use the @JSON be creator annotation, and it will get the fields. Well, you have a field called ID, you have a field called number, just in case the JSON that you're exposing has different fields. And I know my face is on top of the code here. Yeah. You can annotate your arguments here and pass the JSON parameter. So yes, you can use immutable classes even if you're exposing things to a view. And the only other requirement of JSON is that you will need to provide the getters and setters. Okay. And last time to check the chat here. List immutable item, collections dot unmodifiable list. Which one is better from Thiago? Well, collections unmodifiable list creates an immutable wrapper. Probably the list.immutable for Eclipse Collection, the performance is better, but in most of the cases, you wouldn't have to matter about performance. So yes, you could be using both. And another comment from Thiago, this preconditions class is very interesting. I never used it early. It seems it can be used with internationalization. I mean, resource bundle. Yes, if you want to provide different error messages, I don't think it's that useful. But I have another talk. If you check on YouTube, I have another talk where I mention revisiting affected Java, where I mention how is the proper way for you to use resource bundle in internationalization in value objects. It's worth checking. And I didn't realize that it's a lot of content for just 30 minutes, so that's why I intend to record a lot of different videos. How can you apply these concepts in proper JPA entities? So I know it was a very rushed, so I didn't have time to do like a full example because it's only 30 minutes, but it just draws even more interesting for me to be doing this short series of videos and blog posts. And if you want to know more about that, just follow me on Twitter because I'll be posting this, subscribe to my blog, yanaga.io. You'll be able to get much more information after the fact, okay? And that's what I had to tell you for now. I know it's very short. I'm already over time, but I really appreciate the time you spent with me here today. And remember, tomorrow, celebrate 25 years of Java because we, the Java community, we deserve that. Thank you very much. Hope to see you next Friday. And that's all for today.